Welcome everyone to live update to yesterday's kernel, compiler, configuration, CPU bug stuff, you name it. To summarize this in 10 seconds, so I made the mistake of testing too much and copied the latest build of oldest Intel x64 Linux to the Ryzen 3950X compute node here, and had some instabilities, mostly network related, and was analyzing this, and yesterday wasn't clear, compiler misoptimization, CPU bug, who knows. I made a poll here. Actually I thought somehow not really, I want to move on. It's not like my life to analyze every other's people's bugs. Made a tiny little vote. Although you ask microkernel stuff, 164 people vote. You ask some Linux kernel stuff, 32 vote. Anyway, yeah, should I even look into this? Like, yeah, 80ish, 78% say yes, 20s no. Okay, fine. So the problem is, so I looked further into that because I could have just like YOLO, whatever works for me, but I somehow didn't want to continue. I'm here after #peakbugs coming back from macOS. I had already enough peakbugs with macOS and not really running Windows here, so it was more like for our own T2, one of the most vanilla raw Linux distributions here. Certainly I want to have the most stable base here, and I almost like, yeah, I had some overclocking glitches. It's like I rather have some 100% rock solid stuff. So of course I continued to look into this, invested another 2 hours of testings today, and the result is even more bizarre. So yesterday we looked here into the assembly. It was mostly instruction scheduling. This is, by the way, the diff of K8, which K8 worked. No Konar, the very first Intel Xeon with 64-bit AMD there. And I hope you can all read some assembler, if not previous video, their instruction set, architectures of various architectures. So here you see moves is just the same registers, R, D, I, R, so extended destination index, extended source index of 64-bit stuff. Just another tiny little bit offset, otherwise the same instruction here, just moving the same, even same offset here, 218 hex DI. So just exactly this is a kind of scheduling compiler. GCC, Clang have usually 2 settings. Well, between the hundreds of options they have architecture of instructions and architecture, previous videos. So this is like SSE, SSE2, 3, SSE 3, 4, AVX, AVX2, AVX 512, previous videos, agreeing with Linus Torvalds, mostly silicon wasting nonsense. Anyway, so this is the stuff of what kind of instruction set and extensions to use for the latest and greatest single instruction multiple data performance. But of course you would normally not want to use this in your kernel, because if you task switch, if you task switch between user space and kernel space, you have more state to save, and with all the AVX stuff, increasing the size of this floating point single instruction multiplicator coprocessor like cache, of course built in since probably some 486 or so, you increase the state that needs to be saved, and saving state to cache and memory of course costs performance. This is why normally in the Linux kernel they avoid this. They compile with whatever optimization -m no AVX SSE and so on, and unless exceptionally maybe for some RAID code or encryption and so on. But anyway, so also for me this yesterday was surprising how close this is. I would expect all the scheduling to be more and not like just moving the tiniest instructions around. So this was very little change. So I investigated further. I built the Linux kernel. So how did I tackle this? I built the Linux kernel with narrowing down the optimization. You see I have here multiple disassemblies in the meantime, core 2. So everything worked, long story short. Summary is everything worked, core 2, K8, Zenver 2, all of them work. as expected. Obviously, the only thing that did not work is no corner. And I diffed this here with Core 2, also surprise, right? Core. Also, I want to point out one misconception. Someone commented here that no corner, someone here, Stephen Newberry, comments technically. And so, spoiler, this is my opinion, not correct. So what I read now is not my opinion, but in my opinion, not correct. Isn't guaranteed to work on anything other than no corner. Intel NetBurst is pretty different from AMD Zen 3. Does it still fail with generic specific flags? Want to support probably only safe way to compile, make everything work. So actually I used no corner as very lowest previous videos, having this to run on all the old Xeon and whatnot stuff. This is why actually we built with that. As you have and so on. What else do we have? Say it's probably not a bug, but undefined different behavior. So in my opinion, total misconception, because as you probably know from all the backward compatibility with the real mode and stuff, the latest and greatest AMD Ryzen 5000 Zen 3 can still execute all the oldest, maybe garbage 16-bit segmented remote stuff, previous DOS videos. So you could still boot DOS and play X-Wing versus TIE Fighters, Monkey Island and Commander Keen and all the good stuff, of course, certainly with 10,000 if not hundreds thousands of frames per second, but theoretically you could, unless of course your EFI BIOS doesn't boot your compatible mode DOS stuff, but otherwise that should work. So my opinion, if you compile for some Intel Xeon no corner stuff and you have a newer Intel or AMD CPU implementing the same instruction set like SSE2 and whatnot, then of course that should run perfectly fine. Most architectures work like this, PowerPC, Spark and stuff. And the only architecture where this does not work like this is sometimes some stuff like MIPS, because they sometimes have very delicate, especially kernel space, TLB handling, translation local-site buffer handling and other such stuff, or delay slots and other hazard avoidance stuff of stuff that erratas that could stall your CPU, other stuff. Anyway, so yeah, in my opinion, this is also the grief with the modern internet, right? Everyone writes something on the internet and other people take it for perfection. Anyway, long story short, bisecting this, so this took quite some attempts, like 2 hours here of recompiling stuff. And so the fun thing is then I manually built the kernel with no corner, and even that still worked. And then it's like, wait a second. Then the only difference is the automatically generated kconf. And do we still have that probably somewhere, but not here? Oh, this is also not this. So because T2, when you select in T2 stuff like no corner or Zen version 2, it also changes the kernel config option here. In the 32-bit kernel there are many, like even transmeta, VIA and whatnot. For 64-bit there are only 5. 1, 2, 3, 4, 5, I guess. Basically only no corner, so MPSC, because the Linux kernel people couldn't use no corner, of course they used MPSC, that is no corner, the very first Xeon whatever stuff. Then, also not MPSC, M stands for machine, so PSC obviously for, is it Prescott? No corner, anyway. And K8, Core 2, Atom or generic. And in my opinion, if you choose no corner, you probably want this PSC option. If you choose Core 2 or higher, then you probably want Core 2. This is why we hardware this. And the only thing is, as you see from this diff, if you choose no corner or MPSC, it also, I think ironically, the help text even is no corner. So the help text is Xeon no corner, and then this is MPSC, whatever. So the interesting thing is, it also automatically behind the scene changes these options. P6 Intel Pentium Pro, P6 knobs in operation for their kernel patching stuff, I think. Intel user copy, Intel use Pentium Pro checksum. Also, yeah, super sorted and like consistent naming of Pentium Pro and P6 was there. Linux kernel professionals. Anyway, so obviously I thought then, yeah, for sure it's Intel user copy or the use Pentium Pro checksumming stuff, especially as this Pentium Pro checksumming actually has some function header of TCP/IP checksumming stuff. Anyway, so one by one I toggled this manually, and you will not believe, raise your hand. Oh, wait a second, this is, by the way, not all. Actually, this is slightly incorrect. It also changed the L1 cache shift from between 6 and 7. Sorry, this is an interim state here. So of all the options, of course, first I thought, for sure it's this P6 knob thing, probably, but no, it wasn't. I thought, yeah, for sure it's this Pentium Pro checksumming thing. No, it wasn't. Then for sure it's this Intel user copy thing, because what else should it be? No, it wasn't. It was this L1 cache shift thing, to my surprise. I had them all here, so I patched this kconfig here for that. Here of just deleting this, this is P6 knob, deleting here MPSC. And of course, they say the P6 knob works everywhere except VIA, where it might be a little bit buggy, and some virtual PC stuff or something, where it's not implemented. And also here, I mean, funnily enough, I'm not even sure is that it's technically correct. So maybe this is actually a kernel config bug. It probably should be here, because why are all, I think they just forgot this, right? 10,000 or 9,200 something kernel options. I think they've just forgotten MPSC here, so maybe I should send upstream of also use Pentium Pro. We find everything live on this channel, obviously, right? So yeah, I think they forgot this here, but so I patched this in here also. Intel, I'm also totally not sure. I think maybe they just forgot this here also. I've no, because here is M core. Why is here core 2 duo? Why is here K8 but not MPSC? It's like, anyway, all of this stuff was not it. Lo and behold, that is a change. So cache L1 cache shift. This is totally bizarre. So this is totally not what I expected. I expected a compiler optimization bug. I expected this no corner Senver 2 of architecture, no corner Senver instruction scheduling of probably also cost model of how many cycles the instructions take and stuff. I expected everything. I even expected like user copy checksuming, but I totally didn't expect to come back here. It's like, it's this cache option. So this level 1 cache shift here of power of 2. As you see here, they use 5 for ELAN, 486 SA, 486 Geo, GX1. Otherwise 5 for my precious WinChip previous video, Crusoe efficient previous video, Xyrix video coming soon, Pentium I never had, and otherwise, so this is just like how many K they account there for. And I'm not, so I grabbed this already. For me it's not entirely clear, which also I probably should really write my microkernel now. It's getting a little bit boring to fix others people monolithic kernel with all the bugs and stuff. Honestly, a little bit time wasting of my lifetime, to be honest. And anyway, so this is used a little bit all over the place. So this is, if you're wondering why do I grab for L1 without x86, this is defined there somewhere. I also grabbed this with that before, so somewhere they also align here, so entry align that to L1 cache shift as optimization of better layouting, this stuff for better cache efficiency. And they also define here in assembler, inline assembler cache age, header L1 cache to config x86 L1 cache shift. And so this is all over the kernel a little bit, as you see here. And so this is a little bit hard to tell. I would also, however, think, so this, at the end of the story, it's one number, right? One cache size shift number. I expected everything, but not 2021, some bloody 1 power of 2 shift thing there of cache alignment. I'm also not really sure, as you see, in contrast to this comment here of technically guaranteed to work. I would even think any of this layout stuff should work, although they use it here obviously for whatever ACPI, not really sure, command line. Here's also Linux, although we don't use this Broadcom logic of align shift of something, I1 shift. PA risk, obviously, which we're not running today, but previous video. So yeah, I expected everything, but not that. And I will also I will simply not debug this further. So, I mean, what I could do is, I mean, first of all, I leave this patch NT2 because obviously I want my stuff just working. Also, so what does it mean? I'm slightly, although I'm still torn, right, between the perfectionist. It means like, let's find out why this freaking heck corrupts some Ethernet frames. I mean, not all. I think ping goes through, but secure shell does not. That somehow corrupts and mangles Ethernet frames for some bizarre reason. And on both the Ryzen 3950X and the Ryzen 5950X. Given that the problem is also, I only see the bug only with the Intel IGB Ethernet driver. So the kernel boots, so what are the symptoms? The kernel boots, it doesn't even oops, it looks like everything. I can also build stuff, so like 99% of the stuff like NVMe, serial ATA, USB stuff, everything works except Ethernet frames with the Intel IGB driver. Also sure, I could actually test if it works with some other Ethernet card. But yeah, truly bizarre. And although I still wonder between, is this a processor bug of some really bizarre cache corruption, collision, something. Although usually we run here so much stuff here on this channel, compiling whole ISOs here on the Ryzen 5950X and certainly previously the 3950X, of which we actually still have data running here and checking for updates. I have it hard to believe that this should otherwise be a CPU bug, but this is extremely bizarre. But we at least learned a couple of things, including that for the kernel, at least if you're not optimizing for different either instruction extensions like SSE and AVX, the optimization that GCC can do, because I mean, what can GCC do, right? If you optimize between Intel Core i7 whatever and Zen 5000, unless it has like AVX 512 or something, or AVX2 and so on, then of course it can use this new single instruction multiple data instructions, and then the code might be quite different. But on the otherwise, the magic optimization that a modern compiler does is of course only using some alignment, moving some stuff around, like this scheduling, cost and cache and register dependency and so on. But for me, this is also eye-opening. I've looked a lot on different optimization stuff, but I rarely have seen so similar code just moved a couple of lines around. And you might wonder, why does this code even work? Because it's not using registers dependencies. So it can move this from here to here because this moves and ends do not depend on other registers. You see here's moving R13, RSP, and then we have, wait a second, this is to EAX, RD, and then just doing this later. Should not, at least we should, did I even fully, this is, yeah, I mean, probably should be correct anyway. So yeah, this is eye-opening for me of what really to expect from a compiler, because most people always think the compiler is doing whatever magic stuff, but in reality it's like, yeah, just schedule this a little bit different, and the major stuff, of course, using stuff like AVX, AVX2, AVX 512, although the later not very recommended due to the nature of the silicon size. I rather have a couple of more cores than this rarely used stuff. Anyway, yeah, leave me in the comments below what you think. Again, for now, maybe I even send Here's a recurring theme. The next thing was also, by the way, accepted upstream. I sent this QLogic 1280 or so as used in the SG-Octane patch upstream. That is now also accepted. So somehow we have now in each major kernel at least one patch of us accepted here live from YouTube. Maybe I sent the other thing upstream. Not that it. The problem is always the time to send the email is. Okay, for this I used a couple of hours, but otherwise just writing the email takes already so long that. Yeah, but I think I sent this upstream because I think this is just overlooked here, and not that it would matter too much. And this cache shift here, I just patched this in T2 for not using. Where do we have here? All right, I just removed Prescott here. Pentium 4. I think you can't even select Pentium 4 for 64-bit. Anyway, if you have ever looked into that details and have further insight what exactly that could be, but again, given this code, as I said, it's fully backward compatible. It should just work on modern CPUs. I'm really puzzled whether this should be some potentially could still be some AMD CPU bug. I have it super hard to believe given the nature of what complex code we run through there. But debugging this, so how would you tackle that? Debugging this, even more difficult. You could theoretically, because the thing is, right now my only test program is Secure Shell through a network, through at least one specific network adapter, not network interface card. I would need to spend even extra efforts to test on other machines if this is reproducible with other network cards. But yeah, I don't have hours and more days and nights for that. I patch this to just work for me for now, and otherwise I really work on my own microkernel stuff because I want some more quality stuff. All this monolithic stuff is a little bit too fragile and stuff for me. Work around bizarre. I think I type of this message. The problem is, do I have this message still? I can actually check what the message was. Anyway, I hope you learned something from all of this, especially that low-level software stuff is at times really time-consuming, and certainly all this low-level stuff, this will certainly be happening on a recurring basis when we write our own microkernel stuff, especially on MIPS, but also x86 of inter-process interrupts and all this other fun stuff. We will, of course, as we write this, have plenty of memory corruptions and cache issues and whatnot to debug a translation log aside, and page table management stuff, because certainly I'm also human and write this for the first time, so I rather spend my time than debugging this in my own code. Let's see, SSH, did I, just checking here my Google history. I think I googled this message, though I should, because the problem is I never copy and paste it, because obviously with the bug running, with this bug in effect, I could not secure shell and thus not copy this. Are we in Google history? Which day is it even? Do we have here corrupt, truncated? No, of course, as usual, when you need the Google history, you don't find any. Workaround bizarre. Ethernet frame corruption. AMD Zen 2, 3 and till IGB. Yeah, it's it's bizarre. Totally didn't expect that. I've seen a lot, but this is the first. Workaround Pizza Ethernet frame corruption with AMD Zen to Intel. Security. Of course, this could also happen with other Ethernet cards or even other. I just don't usually plug them in and out on a hourly basis. It could also happen with other network traffic. I didn't test that except ping, so it could also be that if you download something curl somewhere or fire up a browser, that would corrupt similarly. Just don't have more data set. But anyway, you see we get here kind of sort of increasingly technically in-depth and low level. Leave in the comments below what you want to see more. I hope you learned something from all this fun stuff. But certainly, last but not least, you really need to look into the detail. And even if it looks like compiler bug, something, at the end of the day, it's like, yeah, some Linux kernel cache alignment stuff versus, yeah. The only thing is, last but not least, the small possibility that this is a CPU bug makes me somehow want to continue this investigation, because finding a real CPU bug certainly would be a once in a lifetime thing. The only thing is, I like totally over budgeted this issue already. Theoretically, I had zero time to look into this, and in the meantime, like 5 hours. Like, thank you very much. Further analyzing this for sure takes another 5 hours, especially if you want to go to the real base to this of finding out, because that could easily, even if you find out at the very end at what kind of situation this happens here in regards to like further changing this to, is it even changing this only selectively for some stuff. Excuse me, it's winter. If you eventually figure what exactly is happening there, even then it might take another like 5 days, 5 working days, or even 5 weeks to like sync spectra meltdown to analyze why this occurs with whatever is going on there between the operating system and the CPU caches. Yeah, crazy stuff. 2021 expected everything, but not that we fiddle around here with cache alignment issues. But yeah, here we are. Hope you learned something. You have some other stuff to do. Thank you everyone for tuning in. Quite some people tuning in. That is amazing. And as I said already multiple times, the recurring theme, we really will continue to do some low-level kernel stuff now. More low-level graphic stuff first with vintage stuff, because the cards are so much easier to work with, getting some better understanding, doing some prototyping, performance work, proof of concept stuff with virtualization, QEMU and stuff, and hope have a lot of fun and learn a bunch of things. Don't forget to like and subscribe for all this fun to come, and stay healthy, and I hope to see you soon for all this fun stuff to come.